first of all look at on that page what is a box and whisker plot, like what's its way of displaying the data set. So in your own words, can anybody give us an idea of what a box and whisker plot does? Besides have some boxes and some whiskers in it? Anybody have any idea what they're kind of doing with that data set when they make a box and whisker plot? Noah?
Use 5.
Okay, you use 5, what they call kind of like critical values, or like five points that help you make the box and whisker plot. And do all 5 points have to are they actually all represented necessarily in the data set? No? Okay, which ones, anybody know which ones for sure would have to be represented in the data set that are in the box and whisker plot? There's 5 of them. Okay, let's start naming them first of all. What's the one at the very end of the first whisker? What's the very first point in the set? I want you engaged here. I want you looking in your books. I want you to answer this question for me. What's the far end on the left called, Abby? The minimum. That's the minimum value. Does it have to come from the data set? Is it going to be one of the data values? Absolutely. It's the smallest one in the set, right? So it's got to be one of the data values. What's the next point? There's 5 of them. We're going from left to right. It's the beginning point. It starts the box. What's that one called? What's that one's role? Cody?
The first quartile.
It's the first quartile. Is that what that one's called? Will you guys verify for me? Is Cody right? First quartile? Okay. Does that have to be one of the data values? What do you think? What's the next one called? The what? The median. Does the median have to be a data value? We've already worked with medians. Does a median have to be a data value? No? It can be the average of some, can it? So if we have to average a couple together, it doesn't necessarily have to be one of the data values, but it has to be something that's representative of the middle of the data set. Okay, what's the next one called? Which one? Third quartile. So it's the 4th point called the third quartile. And then what's the last point called, Faith? The maximum. Is the maximum going to have to be one of the data values? Yeah, we're not just going to randomly pick some maximum from somewhere. It's going to be the highest data value from the set. What a box and whisker plot does is it takes that data set and it divides it into quartiles. Quartiles. How many parts would that mean if I say quartiles? What should come to mind just from our general knowledge when you hear quart? 4. Right? 4 quarters in a year. 4 quarters in a dollar. 4 quarts in a gallon. Quartile. When there's 4 quartiles, we talk about quartiles, we're going to talk about there's 4 of them. So the lower whisker, from the first point to the second point, the lower whisker is the first quartile. The second point to the third point is the second quartile. The third point to the fourth point is the third quartile. And the fourth point to the fifth point is what we call the fourth quartile, the upper whisker also. So we have a lower box, we have an upper box. We have a lower whisker, we have an upper whisker. We have these 5 points that help us make that. Each of those quartiles represents 25% of the data. Now, does that mean they're going to be equal in length then? No. Because a box and whisker plot shows the spread of the data. It kind of like takes the data set, it's just like it says in the book here, it says, a box and whisker plot can be used to show how the values in a data set are distributed. How they're spread, basically. And so we need to find those 5 values to help us be able to make 1. So let's start with number 1 here. We're going to make 2 together in class. Use the data set to make a box and whisker plot. We don't really have any idea what this data set is about. But the first thing we're going to do is we're going to put that data in order so that it's going to help us be able to find those 5 values. Okay, so go ahead and get those in order. Right here in this line where you put those in order. You know how to do that, least to greatest. How many values up here? 1, 2, 3, 4, 5, 6, 7, 8, 9. That better be how many are in my new list. 1, 2, 3, 4, 5, 6, 7, 8, 9. You got to double check that. Make sure if we don't have a good start, it's going to fall apart from there. Okay, so what we do is to be able to find our 5 data values, which we call one of them the minimum, quartile 1, median, quartile 3, maximum. We're going to pick our lowest and our highest for the minimum and maximum right away. We can do those immediately. What's our minimum point going to be? 33. And what's our maximum going to be? 65. So it's going to start at 33, it's going to end at 65, and in between we have to find some medians is what we find. So we're going to find the median of the whole data set first. If there are 9 data values, are we going to land on the median as we come to the middle? Yeah. It's going to be which one?
50.
Yeah, it's this one right here, isn't it? Here's our median. And let's put that right below it, the median. Now, when the median is one of the data values, one of those 5 points, it kind of gets left out to find those other 2 now. It gets left out, it gets ignored for a bit here. So we take now the lower part of the data set from 33 through 45, and we find its median now. So now we need the median of this data set. So, well, there's 4 pieces. Are we going to land on the median? No, what are we going to have to do?
You only have to add.
You have to add. Yeah, we have to add those 2 together and divide by 2. We have to find halfway between them. 36 plus 40 is 76. 76 divided by 2 is 38. So what we're finding is 38 becomes the median of lower half. And I want you to put this in your notes. Median of lower half. The median of the lower half is our quartile 1 value. So our quartile 1 value is 38. Do you remember when I asked that question? Does that quartile 1 have to be one of the data values? And nobody answered it? The answer is no, it does not have to be. It is not. It's 38. That's not one of our data values. It has to be the median of the lower half. Okay, you find the quartile 3 value now. It's the quartile 3 value. Do you agree with me? I say quartile 3 value is 58 and a half, 58.5. 55 and 62 are the middle values of the upper half. Add them together, divide by 2. We have the median of our upper half, which becomes our quartile 3 value. There's our 5 critical values, of which how many of them are actually data values? In this one, not 2 and not 4. In this one, it turns out to be, okay, people, come on. Is 33 in the data set? Yes. Is 38 in the data set?
No.
No. Is 50 in the data set?
Yes. All.
Yes. Is 58 and a half in the data set? No. How about 65?
Yes.
Yes. So my point being here that not all of those 5 values, those 5 critical values that we find have to be a part of the data set. The data set gets used to find them, but they don't necessarily have to be some of our data values. Okay, so now the next important thing with the box and whisker plot is that you are making a good number line, and I've already done that for us. But then when you're making your box and whisker plot, thanks guys, when you're making your box and whisker plot, you use a straight edge to help you make good whiskers and good boxes. Okay? So we're going to plot our 5 points, our 5 critical values, and as we're plotting them, we're just going to draw our box and whisker plot. So our first one starts at 33. What's the number line that I drew for you going by? It's going by 5. So we have to make a good decision where 33 is, between 30 and 35. You want this not to be a deceiving graph, but a box and whisker plot that is good for the reader. So where's 33 about?
Halfway.
A little bit more than halfway, isn't it? 30 and 35? What would halfway be? 32 and a half, so we have to go a little more than halfway, don't we? 3/5 of the way over. Okay, our next data value is at what? 38. So now we go put a point straight across from that one at 38. Again, that's a little more than halfway between 35 and 40, isn't it? Now with your ruler, draw your lower whisker. There's the first part of our box and whisker plot. The lower whisker gets made with the first 2 points. That represents 25% of the data. Okay, now we're going to make, our next point is at 50. So that we should be able to go straight up from 50 on the number line. We do not make the box and whisker plot on the number line, we make it above it. Okay, here's what we do with this one. We draw a vertical line segment going through it first of all. So you draw a vertical line segment that the point is halfway between, from top to bottom. We're going to go do the same thing at the quartile 1 value. We're going to draw a vertical line segment, that length also, with your straight edges. Aurora, could you sit up, please? Thank you. And now with your straight edge, make the rest of the rectangle that you need to make the lower part of the box. So there's our second quartile, known as the lower box. It represents 25%, the spread of 25% of the data. So if you were in the 25th to 50th percentile on the NWA math test, your score would fall in this quartile. Okay, now we will go graph our next critical value point, which is 58 and a half. And is that a whisker? Yeah, we're going to make the upper part of our box with this, aren't we? So we're going to put a vertical line segment through that one. And then we're going to finish off the rectangle, making our upper part of our box called the third quartile. So now, if you scored in the 50th to 75th percentile on the NWA math scores, or on the ACT test as a junior next year, this would be where your data value would be, in that third quartile. And then last but not least, we plot our maximum, which is 65. And we draw our upper whisker. Now, let's just do a little bit of evaluating here, okay? Because a box and whisker plot is good for some things and not so good for others. Can you think of one thing it's not very good for if you're just looking at the box and whisker plot? What would not be very good for? How many what? How many cats your aunt has? So if this data set represented the number of cats. So was it 30 cats, or 33 cats? At the first house she lived at, the next house she lived at had 65 cats, the next. It's a scary. Yeah, it is a scary thought, isn't it? Cats? Okay. How about let's treat them as, I hope this will never be the case for you guys, but let's treat them as math scores. What was the lowest math score?
33.
33. What was the highest math score?
65.
65. Whew. Only one of those is passing, right? Yeah. Okay, so when you look at the box and whisker plot though, and you don't get to see the data set, would you be able to tell from the box and whisker plot what all your scores were?
No, we should be able to tell that person.
And you could tell which scores? Yours?
What are all yours?
Oh, really? You could, because you know yours, right? Okay, that would be the only reason though, is because you know it. If I just gave you guys a picture of a box and whisker plot and said, here is a box and whisker plot of the last test, the one let's just say you took from yesterday, or Friday. You took this test on Friday, and instead of giving you the test back, here's what I do. I give you a box and whisker plot, and I say, here's how we did as a class on this test. Would you be able to tell what you scored? Would you be able to tell really what anybody else scored?
No, we should be able to find two at the lowest, two at the highest.
You'd at least be able to estimate what the lowest score was and what the highest score, and you'd be able to estimate what the median is, but would the median necessarily be somebody's test score?
No, but it's
Not
close.
necessarily. So one thing that the box and whisker plot doesn't do is it doesn't show us the data set, does it? There is no way. It's not like a stem and leaf plot. When you look at a stem and leaf plot, can you tell what all the data values are? Hey, gang!
You don't want to answer question.
I don't, you're right. I'm talking to the rest of these numb brains this morning. Can we tell in a stem and leaf plot what all the data values are? Oh, let me show you a stem and leaf plot.
The numbers up. We have to take the same number.
Can we tell all the data values in the stem and leaf plot?
Yes.
How many data values are there in it?
6.
6. There's 6 leaves, so there's 6 data values. 33, 30,
7.
7, 30,
8.
40,
1.
50,
0.
there weren't any. 60,
2.
2, 60.
7.
We can tell what the data values are in the stem and leaf plot. How about in this box and whisker plot?
It only gives us a range.
It just gives us a range, doesn't it? We can estimate what the minimum is, we can estimate what the maximum is, and then we can say, here's the range of the data values. Well, we can't see what all the data values are. Okay, so we can't do that with the box and whisker plot. Okay, what can we do with it?
Estimate.
We can estimate. And we can see how far the spread was of the data. We went from 33 to 65, about, that's what because what we have to do is we have to use the number line to look, and we're not exactly sure if it's 65, maybe it was 65.5 for all we know. We don't know for sure. So box and whisker plots are kind of limited what they can tell us, but they do show us the data divided into quartiles. So the shortest quartile kind of looks like it could be the lower whisker, but the upper whisker's in kind of good contention with it. So the bottom 25% of the data values does not have as big of a spread. Where's the biggest spread of the data values in this box and whisker plot?
From 40 to
From about little less than 40 to a little more than 50, right? There's the biggest, it's the longest part of it. Doesn't mean there's more data values in there. How many data values do you think would be represented in each quartile? Looking at our list, how many data values are represented in each quartile? About each quartile? How many data values are there altogether?
5.
No, 9. 4 quartiles, 9.
It'll be about 3 in each one, so no, 4.
2. 9 divided by 4 is But yet, the spreads are different because it's saying from one end of it to the other end of it. Okay, let's go to the back side and let's do another one. Use the data set to make a box on this plot. Okay, go ahead and get it ordered. First of all, that's the first thing you need to do. Get them in order from least to greatest. On your own. On your own. Then you can compare with me. How many data values do we have this time? 10. Okay. By now, hopefully you have figured out the difference between having an odd number of data values and having an even number when you have to find medians. So on the front side, did we have an odd number of data values or an even? Odd number, 9 is odd. Could we land exactly on the median? Was the median one of the data values? Yes. Or when there's an even number of data values, can we land on a data value in the middle? No, we can't, can we? We're going to have to find an average. So let's first of all identify, what is our minimum for this one? 15. What's our maximum? 28. Okay, so if there's an even number of data values, that means the median is halfway between those two, right? So do we really have to add those together and divide by 2, or do you think we can tell what the median is? Yeah, it's halfway between, 24.5. This is our median of the whole data set. That is our middle of the 5 data values. Doesn't mean it has to be in the middle of the spread. It's just the third of the 5. Okay? Now, how do we find that quartile 1? What are we going to do? Yeah, we need to find the median of the first half, the lower half. So what is the median of the lower half? 16, it's right here. Median of lower half, and I want you to put this. That becomes our quartile 1 value. What's the median of the upper half, the second half? The second 26. So here's our median of the upper half, which becomes our quartile 3 value, they call it. Okay, so notice I make the number line for you, but how do you think I decide how to even make it? Because can we ever show the whole number line?
No.
No, we can only show a snapshot of it. How come 0 wasn't included on this?
Usually it says the start near 0.
Where does it start?
It starts at 15.
It starts at 15. So we want to have some spread though off to the left and off to the right. So if it started at 15, I decided, you know what? I got to start less than that. It ends at 28. I have to go more than that. What am I going to go by on the number line? So I decided to start at 10, end at 30, and go by 5s. Go ahead, you make the box and whisker plot now without me. You just get it on the front. You do it all on your own. straight edge, I just didn't, and I went back and erased. Okay, which quartile has the least spread? Least distribution? Cody says third quartile. Anybody want to agree with him? No, you can't. Abby? You're going to agree with him? Okay, Abby's agreeing with Cody. Anybody else want to agree with Cody? It's the third quartile? No? You're going to agree with him? Okay. So who wants to go with something else then? Besides Cody. Cody wants to change his answer, but we'll see if he wants to change it to what you have. Miguel? Yeah, there's a shorter distance between these 2 points than there is between those two and the third quartile. It's the first quartile that has the shortest, smallest, least distribution, least spread. Which one has the greatest? Absolutely. The lower box is the biggest spread of the data value, and so it's going to be called, it would have the greatest distribution, the second quartile. Okay. How many data values were in this set looking at the box and whisker plot? How many data values were in this set looking at the box and whisker plot? Is that a straight edge? I don't know. Look at here. Look at that box. That's skinnier than that one. That's not going to be a good box and whisker plot. How many data values looking at the box and whisker plot were there in this set? We can't tell. We don't have any idea. The box and whisker plot does not, just looking at the box and whisker plot does not allow for that. We can make these kinds of calls. We could say the first 25% of the data values fall between what and what? We can estimate 15 and 16. We could look and say, it looks like this point is above 15. Maybe that one is 16. I don't know. Maybe it's 15 and 3/4. Who knows what we could estimate. We could say what the median we think of the data value set is. We could say what the maximum is. We could estimate all these things, but we aren't really certain exactly what they are or how many data values are represented in this. Okay. And when you are doing your homework, they're going to have some box and whisker plots are already made for you, and then you're going to have to answer some questions based on what those box and whisker plots look like, and they're not going to have given you what the data sets were to begin with. They're going to ask questions that you're going to have to, looking at the box and whisker plot, make decisions from, interpretations of. Okay? Anybody have any questions?